Hi, everyone. Thank you for joining us today. And I want to especially call out Brian at CFE for making today possible and accessible. And as mentioned earlier, I'm really thrilled to be here as I've been part of Front of Foxes for just about 2 years now, helping with the bootcamp curriculum and overhaul of that, as well as community engagement. Thank you to Jen Looper, the founder of Front End Foxes, for creating this amazing and growing worldwide community. It's really amazing to see the array of events that we've put on over the last couple of years with online workshops and roundtables and streaming. So I'm just excited to see where it can take off from here. All right, so I'm Jaeriah. You can find me on Twitter at my first and last name. I will also be uploading a blog format of this talk after on my personal website at jaeriah.com. Please feel free to reach out. I'm more than happy to answer any questions if we're not able to get to any questions in the end. All right, so I want to get just a bit of my background out of the way before we get to talking on one of my favorite current tools. I work remotely for a company called Tackle as a software engineer based out of Vancouver, BC. My day-to-day at Tackle is spent building a software platform that enables other software companies to generate and scale revenue through cloud marketplaces. So some of the big ones are AWS, Azure, Google Cloud, and Red Hat. Since starting at Tackle, I've been exposed to working with some of the most modern and innovative tools, one of which is GraphQL, and why I'm here today. A tool that I've been intrigued with and eager to learn about since starting my tech career just a few years ago. And I want to assume that a majority of you have heard of GraphQL, but if not, that's even better. I'm here to give a bit of an overview of GraphQL, what I've learned, and why I believe it is a powerful and intuitive tool to abstract, manipulate, and consume data in your modern front-end applications. And my only hope is that by the end of the talk, GraphQL won't just be some hyped up jargon made-up word that you nod and say yes to by the mere mention of it, because that was me just a few months ago, but that it would be a tool that you could dig more into and leverage for your next project or application. Let's go over the agenda for this talk. First, I will start off by touching on the comparison between GraphQL and the traditional REST architecture. And right after that, I will go over exactly what GraphQL is and give some examples of how to integrate it into your application. I will then summarize some of the benefits and what kinds of problems it could solve, along with the drawbacks and when not to necessarily reach for the tool. And then I will close off by recapping on what we've learned. Before I get into what exactly GraphQL is, let me make a comparison with what most of you might be more familiar with, REST APIs. Let's imagine a real-world scenario here, shall we? We are all affected by the environmental damage that's happening in real time. And not to dispirit with what the world is currently facing, but more so to continue to spread awareness in hopes to encourage atomic and industrial changes that will help to hopefully reverse the climate issues. Let's say you're curious to visit a curated list of climate initiatives that you would like to get involved with. This slide shows an example wireframe rendered from a request that was made to a REST API backend. So how the REST architecture works is that it relies on a set of rules. And one of the rules states that a piece of data, like the listing of climate initiatives, resource, for instance, like you see here, is fetched when you link to a specific URL or endpoint. Sorry, just working out my, okay. The slides, so what you saw earlier was a list, an array that is output onto a landing page. And you would go to a URL like this one that you see here, and you ask the REST API to give you the list of initiatives available at this endpoint. How this works exactly is that when you visit the URL, it determines what response comes back. The data is typically returned as a JSON or JavaScript object, and it may look something like this. At first glance, you can see that that is a whole lot of data and nested properties. The limitation is that the RESTful architecture already defines what the resource looks like here, and you really have no other flexibility than to return it all to the front-end client. there isn't an intuitive way to know what structure your data might come in or what type the document you're requesting for would be. You might say, it's premature to look at a potential problem on a smaller application. But when you're thinking ahead of scaling an application with multiple pages and specific views, it will become cumbersome to create different endpoints and queries to receive the relevant results for your front end. Take, for instance, you're given a new view to implement where you need to display a list of categories for a specific initiative. You will run into a situation of needing an API endpoint for each front-end need. To demonstrate this caveat, let's go back to our climate initiatives example. If we need an initiative details page, we would need to create an endpoint that returns a specific initiative by its ID along with its corresponding data properties. The second line shows an example endpoint you would also potentially need to create if you want to return the list of categories for a specific initiative. This could get quite unwieldy with having to duplicate code because of the need for either a full set of data or a sparse set of data. Using different resources to model needed data is considered a conventional REST API architecture, as opposed to creating a single endpoint that returns the entirety of an object and all the records associated with it. There will always be some trade-offs when developing for various front-end clients, especially if you have multiple ones like mobile or web. You will need to think of serving various subsets of the same data and what other associated records you might need. It ultimately comes down to the business logic and whether the project is more front-end or back-end driven. The main issue that is prevalent in the REST architecture is overfetching unwanted data that the front end doesn't necessarily use, and also having to make multiple trips to cater to different queries. The contract and communication between the client and the server is fairly one-sided because the client is forced to receive what the server gives. To iterate the drawback visually, here's a diagram that shows how the network request works with the REST API. So you can see at the very top, our client here relies on 3 different entities for data, which means 3 times the network request to get the necessary information that we need. Is there a way that we can reduce the number of calls? Yes, there are definitely ways to do that. For instance, like batching the categories API together to get the list of categories for initiatives listing. But this method might not necessarily scale, as there is a tightly coupled development workflow with the backend and front-end teams, where the backend needs to continue to be altered to suit the precise needs of the front end, especially if you're given new specs, new projects, and new apps to work on. The other method would be to use one single endpoint, like I mentioned earlier, but then you're getting a whole lot of data back you might not use, and that will come at a cost for your performance. So when there are problems and limitations in the ever-changing web space, new tools inevitably always surface in an attempt to solve them, especially in today's front-end web ecosystem. That's when GraphQL was created by Facebook to solve some of the challenges with a whole new different paradigm of working with data in the front end. In 2022, the State of API survey collected answers from what tools are being used worldwide, with representation from a wide variety of organization sizes, experience levels, and industries. The survey concluded that the number of developers using REST in production fell slightly, while GraphQL increased in familiarity and usage. As with any new front-end tool, you don't necessarily choose to jump on the bandwagon just because it's the next hot thing. I will go into more details on the drawbacks and when you don't want to integrate GraphQL in a much later slide. What exactly is GraphQL by definition? That is a great question that I haven't covered yet. The GraphQL Foundation lays it out as it is a query language, what the QL in GraphQL stands for APIs, and a runtime for fulfilling those queries with your existing data. GraphQL provides a complete and understandable description of the data in your API. It gives the client the power to ask for exactly what they need and nothing more. And it makes it easier to evolve your APIs over time and enables powerful developer tools. So those are a whole lot of words, but let me break it down and get into it a lot more. What I like to do is define GraphQL into these umbrella concepts. It's essentially a data graph, a query language, and a schema. And I will get into each of these concepts later on. Rather than going back to the explanation of the quote, let me continue to paint a visual model for you. Take a look at this visual graphic, which of course is GraphQL's official logo. It might not be so telling from first looking at what the logo is trying to portray. The dots, each of these dots are what GraphQL represents as nodes. Nodes are individual objects, and the lines that connect these nodes are what we call edges. Edges corresponds to the relationship between these nodes. Going back to our climate initiative example again to shed more understanding, each of the nodes represents a particular resource, like the initiative, an article, or a company, for example. The edges would represent the interrelationship between the nodes, like what category an initiative is in. This is what your data graph essentially would look like. GraphQL basically works on the concept of graphs, and the relationship between the objects in the graphs are treated as first-class citizen. How exactly does GraphQL Server make working with data more intuitive for the front end? This visual is a bit of a stark comparison between the REST API that I showed you earlier. It shows a GraphQL layer sitting between the client app and your database or microservices. The GraphQL server receives the request from the front end, and it would consult with a schema that is provided, which I will show an example of later. And then it would respond back to the client with a JSON document. And you can render this out exactly how you need in your front end. I will start by showing you how you would create a view or component based on a UI and how the operation and implementation of GraphQL works. Let's consider a climate initiative again with a details page like so. You can see that this page is rendering out a name, image, website, and description. And how this is displayed out is exactly how your query is asking for it. And going into more of the implementation side of things, there are two ways to implement GraphQL. You can either do it as a schema approach or a code-first approach. Which one you go with fully depends on your project's requirements. I won't be going into details on using a code-first approach, but instead, we'll go over how a schema-first approach looks like. You will see later on how a schema-first approach enables more readability and discoverability for your code. To start implementing GraphQL with a schema-based approach, start with breaking the steps down in these components here. So you would first start with a data graph by defining your schema and your types. And an example of our initiatives detail page, a query that we would make would include the field's name, website description, and the query would look something like this. But before the query can even get executed, it would need to be validated on the server to check that the types are correct and whether they exist. Luckily, GraphQL uses a type system for validation on the query sent by the client. We would define our field types like so. There are two defined types here, our image type and our initiative type. The validation of the query will be done against the initiative type and the image type as well, as it is one of the nested field properties of initiative. If we ask for, say, an article field in our query, the GraphQL server would respond with an error outlining that the article field simply does not exist on the initiative type. Secondly, the server would need to know exactly where we are retrieving our data from, be it a database or microservices. I will just briefly touch on what resolver functions are, but I won't get into an implementation of it as it can get quite complex. So basically, what a resolver function does is that it tells the GraphQL server where to fetch and how to resolve the fields. for the brevity of this talk, it is simply just a resolver function that can be written in any language, where you're able to drill down to the specific field and the exact data you need from multiple endpoints. So an example may look something like this. Once we've defined our schema types, we can write a query to ask for the exact information our client app needs and have an expected and succinct response from our server to use in our front end. You can use the query here and ask for the fields it needs and nothing more. And you can see that the response is given with the exact properties that you need. And you can sparse this out, render it out exactly how you need in your front end view. So with all that said, let's summarize what benefits GraphQL serves and what problems it aims to solve. GraphQL allows you to dictate what the required data for your distinct front end would need. And the retrieving of data would use a single endpoint to get the response according to the schema you provide. One of the main advantages I'd also like to highlight is the incredible developer experience and the ability to incrementally adopt GraphQL into your projects with separate client entities. You can start introducing a new feature or one domain of your application without having to overhaul everything in the beginning. And this is how we've done it in my team at Tackle, where instead of overhauling our whole API backend, we start with one domain area and work with that to introduce new features. Developer experience encompasses everything across the GraphQL ecosystem, from the documentation to the built-in type system and the decoupling of backend and front-end services, and how easy it is for front-end developers to reason about their code. It's really giving the power back to the front-end developers. Lastly, one more benefit that's worth mentioning is that GraphQL has been adopted widely by bigger enterprise for their complex systems and microservices, where multiple client applications are needed. Of course, there's no tool that is one size fits all. What may be some reasons of why you would not want to reach for GraphQL, and what are some of the drawbacks? Because GraphQL is has such an intuitive developer experience, there are a lot of complexities that happen under the hood that are abstracted away. A lot that I don't necessarily know about at this stage, like the extra services it provides or that it doesn't provide. And this may contribute to the tool of being more of a black box, where it may be difficult to debug. GraphQL isn't necessarily a successor or replacement for REST, which is worth mentioning, or your database. It is simply an agnostic query language to ask for data from your backend. It also might not necessarily be worth integrating GraphQL if you're not working with a rapid changing system or introducing new features, or if you're working with a small project. So if you have an API backend that is quite consistent, the engineering effort that's needed to implement a whole server might not be worth it. So I have come up to the conclusion of my presentation here, and I want to close us off by recapping on what we've touched on. Everything that we touch on is at quite a high level, and I wasn't able to really drill into doing an implementation demo of it, but I'll be happy to share more resources of how you can read more about GraphQL after my talk. So we've compared the differences between using a RESTful architecture, and there are issues with overfetching, underfetching of resources, and not having to make multiple round trips for data. We went over the steps of how you would integrate GraphQL at a high level by defining your schema, types, and requesting your data for the front end with your specific query. From that, we understand how exactly the GraphQL operation works. We briefly touched on what resolvers do and when you would need to stitch data together from multiple entities and how your data can be resolved. Then I showed you an example of what a query might look like and the predetermined response that you would get. All right, I hope that everything I've gone over has gotten you a bit excited to dig deeper and learn more about this new paradigm of working with data. Of course, I'm no expert at all. This was simply a new tool I started working with and wanted to share some of my understanding and learnings. I want to thank you all for being here and for listening. And once again, thank you to Jen, thank you to Brian, thank you to all the MCs and all the wonderful speakers that I can't wait to catch up on the talks with. I was able to kind of dip in and watch some of the talks. I can't wait to catch up on them later on. And once again, feel free to reach out and connect on my Twitter, my website, and yeah. So this wraps up my presentation. Thank you so much.
Okay, so thank you very much, Jaeriah, for this really insightful and informational presentation. I do have a question to ask. Do you think GraphQL will be replacing RESTful API anytime soon? Do you think foresee a future or like in the nearest future?
Yeah, at this stage and with my experience level working with GraphQL for the first time in an enterprise app, I'm of the opinion that it's a very specific use case where you would reach for GraphQL. With GraphQL, the benefits that it provides can also be its drawbacks. So I think ultimately it depends on the specific business logic. Say, if you're looking at putting in all the engineering effort to implement the system as a whole, or would you do it at an incremental adoption process? I think there's still a lot of work to be done with the tool. And right now with, Facebook being having a core team to work on it, they will continue to solve problems that come up with the Facebook app and across the ecosystem. So I would say it's at this stage it's an agnostic tool that you would continue to use on top of your REST APIs and how it can work in tandem together depending on your application or your business logic.
Okay.